In this video, we are going to do some factoring, but we're going to start with a multiplication problem that we will refer back to help us understand the factoring later. So we're going to start with multiplying together two binomials, and so I went ahead and set up the boxes just to help me organize this, and I'm going to put x squared and positive 3, and then an x and a minus 2, or negative 2. And then I'm going to go ahead and multiply these together. X to the second power times x is x to the third power. X to the second power times negative 2 is negative 2x to the second power. 3 times x is 3x. And 3 times negative 2 is negative 6. And then let's see if we can combine any like terms together. But notice that actually none of these are like terms. And so our standard form, I'll start with the biggest exponent, so x to the third, and then the next biggest exponent, minus 2x to the second power, plus 3x, and minus 6. And so again, notice that we cannot combine these together anymore because they are not like terms. And so that would be our most simplified standard form. All right, we're going to refer back to this in a minute, but what we're going to do next is a factoring problem. And we are going to factor this polynomial, which you may notice is the answer that we got right up here. So when we factor this, we should actually end up getting this answer. We should get the factored form again. So let's see if we can figure out how to do that. So far in class, we have mostly been factoring polynomials with just 3 terms, but notice that this polynomial has 4 terms. And so the way that we are going to factor this, it's called factor by grouping. And this is a new strategy that we're going to be using when we have 4 terms in a polynomial. So what I'm going to do to start, I'm just going to rewrite this polynomial. And then we are going to group some of these terms. And what I mean by group is put them in parentheses. So we're going to put the first 2 terms together in a group. And we're going to put the second 2 terms together in a group. And then looking back at our multiplication problem, notice that our groups, so these 2 terms, are just the rows here in the box method, right? In this group, that's these 2 terms. So what we're going to consider now is, can we factor out a GCF, or a greatest common factor, from each of these 2 groups? And so let's consider this one first. We need to figure out what is the greatest common factor of x to the third power and negative 2x to the second power. And that would be x squared, or x to the second power would be our GCF, or greatest common factor. So we're going to factor that out from this group. And so we've got to undistribute now. X squared times x would be x to the third power. And x squared times negative 2. If we multiplied those back together, we would get negative 2x squared. So we factored out the GCF from the first group. Again, looking back at our multiplication problem, right, these were our 2 terms in this group. Notice that when I factored out the GCF, I got this, x to the second power. All right, back here, let's look at our second group and figure out what its GCF is. So a common factor of 3x and minus 6 would be 3. So we will factor out a 3. Notice I still have that plus sign there. So I'm factoring out a positive 3, and then what's left in the parentheses would be x, right? 3 times x is 3x, and a minus 2. So again, notice that when I factored out the GCF from this group, which were these 2 terms, I got 3. I got that number. All right, so now looking at what we've got here, notice that this set of parentheses, x minus 2, is the same as that. So what this is showing us is that this right here, this has a factor of x minus 2. And this, all of this right here, also has a factor of x minus 2. So what I can do is I can factor out this common factor of x minus 2. So I'm going to factor that out, x minus 2. So it's like I'm factoring this out of both of these. What I'm left with is x squared plus 3. So I factored out the common factor, and left with x squared plus 3. And notice that those were our original factors up here, written in the other order, right? So this method is called factor by grouping. We sort the terms into groups, we factor out a common factor from each group, then we factor out this common factor, and we're left with that, with these two terms. All right, let's try another one. So we are again gonna factor by grouping. So I'm gonna start just by rewriting our 4 terms, and then we will put them into groups. So we'll put the first 2 in a group, and we'll put the second 2 in a group. And then we need to factor out common factors, the greatest common factors. So the GCF here would be x to the 2nd power. And then we would be left with, well, this would need to be 2x. And then I factored out an x to the 2nd power, so this would just be a -1 now. And then from the second group, a common factor is 5, so plus 5 times, this would have to be a 2x, and this would have to be a -1. And looky there, we ended up with the same things in both sets of these parentheses. So now, this part of our expression has a factor of 2x minus 1, and so does this part of our expression. So we're going to factor out the 2x minus 1, the common factor. So we're factoring that out, and we're left with x squared plus 5. And there we go. We have factored our polynomial. So keep in mind, anytime you're factoring, you can check your answers either by graphing both the standard form and the factored form and make sure that their graphs are the same, or you could multiply these back together and make sure that you get this. So I'm going to end this video by leaving you with one more to try on your own, and I'm going to cover up the answer so you can't see it yet. So I'm going to leave you with this to try on your own. And what I suggest you do right now is pause this video and try it. And then I'm going to reveal the answer so you can check it. So pause the video now. All right, did you actually pause it? If not, you should really pause it and try this on your own. And if you have, here's the answer so that you can check your own work.